Let's move on to question number 174 of set HH. The question says that following solutions were prepared by mixing different volumes of HCl and NOH of different concentrations. So first is we have 60 ml of m by 10, that is 0.1 molar HCl, and 40 ml of 0.1 molar NaOH. So let us first try to calculate what will be the concentration of H plus ions for this ones. So all I have to do is simply multiply this to get the number of moles, and I'll have to subtract this many number of moles because those many H plus ions will be converted into salt by this many OH minus ions. It's simple chemistry because NaOH is going to furnish OH minus, HCl is going to furnish H plus. So as many OH minus ions are present, they are basically going to counteract the number of H plus ions. So effective number of H plus ions that I have in my solutions will be 60 into 10 power minus 3 because it is in ml into 0.1 minus 40 into 10 power minus 3, 40 into 10 power minus 3 into 0.1, which is the concentration of NaOH, and this will be the number of moles of my H plus. To talk about concentration, I'll have the total volume is 100 ml, so 100 into 10 power minus 3. So this is basically 10 power minus 1. If I can cancel it out from these two, I'll get 10 power minus 2 over here. And if I simply solve it out, I can that 0.1 will come out to be common, and 0.1 into 6 minus 4 is basically, so my concentration is going to be 0.02 molar for my hydrogen ions. So I'll write it down over here. My concentration of H plus is equal to this. This is the number of moles furnished by HCl. This is the number of OH minus furnished by NaOH. There's going to be subtraction because as many number of H plus are going to get neutralized by this. So my total concentration is divided by the volume, that is 100 ml, is going to be 0.02 molar. Similarly, if I try to calculate for the for option B, that says 55 ml of 0.1 molar HCl and 45 ml of 0.1 molar NaOH. Since you know the total volume once again adds up to 100, I can simply skip one step. I can say that concentration of H plus NaF. So once again in the denominator I'm going to have 10 power minus 1 because my overall volume is 100 ml. And once again this 10 power minus 1 will be cancelled from these two 10 power minus 3 to give me 10 power minus 2. And I'll simply have the subtraction of 55 minus 45. So this is how it's going to look like. I have 10 power minus 2 common because this is the common factor. Once again, I have 0.1 molar concentration. This is once again going to come out as 0.1 molar into 55 minus 45 is 55 minus 45, which is nothing but 10. So this 10, 0.1 cancels out and I get 0.01 molar as the concentration of H plus ions. Coming back to the same thing for the option 3, I can have, so this is 1 by 5, so that is 0.2. Once again, the total volume is 100 ml, so I'm going to have the same cancellations and I can write concentration of H plus is equal to 10 power minus 2 into, now mind you, this time my molarity is 0.2, that is 1.5, 1 by 5. So it is 0.2 into subtraction of 75 minus 25. So 75 minus 25 turns out to be 50. 50 into 0.2 is basically 10, so let's just write it down. 2 into 10 power, so 50 into 0.2 is basically my 10, and 10 into 10 power minus 2 is 10 power minus 1, that is 0.1 molar. I don't have to solve for option 4 because I have same concentration and same volumes of HCl and NOH. So they are going to cancel out each other. So this is anyway out of my question because all of it is going to be neutralized and I'm going to have a pH of a 0. It's a neutral, so pH of a 7 because solution is neutral. And coming back, my pH is basically minus logarithm of concentration of H plus ions. And I need this to be equal to 1, and that means my concentration should be 0.1 molar. Hence my correct option is 3 because my pH is equal to 1 for minus log of 0.1, that is 10 power minus 1, and it comes to be 1. Hence, the correct option for the question number 174 is 3, 75 milliliters of 0.2 or m by 5 HCl plus 25 ml of m by 5 NaOH.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.